RPIIT Medical and Technical Campus. Today, the topic for the day is types of redox reaction. So earlier we read about what redox reactions are. So those reactions in which oxidation as well as reduction takes place simultaneously are called the redox reactions. So the first one, the first type is this combination reaction. So it is basically the simplest reaction, or in general we can say that when a particular substance A combines with another particular substance B, when they both combine, it's called the redox reaction. Means the formation of two substances is called the redox reaction. So here's the example, that is when the hydrogen gas combines with the oxygen gas, two molecules of water are formed. So this is basically the simple reaction, or we can call it the combination reaction. So combination itself tells what is. It is the combining of the two elements or the two substances. Moving on, the second type of redox reaction is the decomposition reaction. We also know what decomposition is. Decomposition is breakdown of something. So when a particular substance it breaks down into two of its constituent elements, that is called the decomposition reaction. So basically it is just the reverse combination. It is just the reverse of the combination reaction. Means here the substance was being formed, whereas in this case the substance is getting decomposed, that is it is breaking down into two of its constituent elements, means like this. So here the decomposition takes place. Also the breakdown of chemical compounds, means earlier we got to know about, means there was a combination of the compounds, but here the combined element or the combined means the substance, it is getting it is just breaking. Third is a single replacement reaction. Single replacement reaction is when two elements combine. So one of the elements from the first one, it combines with the other reactant. So it is the movement of, the replacement of one of the elements with the another in the reactants is called the single replacement reaction, or in general we can say that AB plus C is equal to AC plus B. Though it seems like as if it is a mathematical equation, but it is not. It's just the combining of one of the elements of the reactants with the other in the products. So it goes like this, where this is like this, like when chlorine it acts with NaBr, that is sodium bromide, so it displaces the bromide and then it combines to form NaCl. So here what is the basic funda behind this? It is like when it depends upon the reactivity series. So which one will be the more reactive, so it will displace the other element. Similarly, because this was the single replacement reaction, we have got the double displacement reaction as well. So in double displacement reaction means either of the two reactions, means each one from the two reactions, they combine with the other in the products. So here we can say that like AB plus B, it can be CB. When they both combine, so each of the two elements means one from both of them, they combine together in the products. For example, it will form AC plus BD. Now again, for example, MgSO4, magnesium sulfate, when it got reacted with the sodium chromate, so what it formed was the product like this. So means double displacement means there will be the displacement of two elements. Moving on, combustion reaction. We all know what combustion is. Combustion is when we burn something. Now burning takes place only in the presence of oxygen. So it involves oxygen. So as burning needs oxygen, similarly this combustion reaction also needs oxygen. Also it liberates a high amount of energy, or sometimes this energy is liberated in the form of heat whenever combustion takes place or the burning takes place. So it is highly exothermic. Now let's take the example, that is when this ethene reacts with oxygen, it forms carbon dioxide plus water. So this is nothing but the combustion reaction. And moving on, because we have just now told you about that it involves oxygen, the presence of oxygen is required, but this is science going on, so we have got exceptions in every cases. So basically this is not the excess, this is the exception. So 2 of titanium, when they react with nitrogen, titanium nitrate is formed. So this is the exception over here. Now disproportionate reaction. What a disproportionate reaction is? That is, when a single substance, it undergoes both of the processes. Earlier, right from the beginning, we are taking two atoms, two elements, or the two substances at a time. But now, in the disproportionate reaction, what happening is, we are taking just one single substance and it is undergoing both the processes simultaneously. For example, let's take A2. It's having the plus 2. It's A2. Or we can say 2 of A or simple A2. Here, one of the substances is getting oxidized, whereas the other is getting reduced. Means the same substance undergoes both the process of oxidation and reduction. For example, here, hydrogen peroxide, it undergoes reduction over here and oxidation over here, because the oxygen is getting detached from hydrogen peroxide when it moves, when it combines to form water. So it is getting detached. There is a loss of oxygen atom, so it is the reduction resultant, and this is the reduction resultant, and this is the oxidation resultant. I hope this video is quite clear to you and the content as well.